Good afternoon, Geometry Honor students. So Mr. Chen again. So today it's a day 5 lesson. So for chapter 8-4, section 8-4, Triangle Proportionality Theorem. So the lesson objective today, so apply 3 theorems frequently used to establish proportionality. Okay, so we'll talk about those type of theorem within this lesson. So let's start with the warm-up. So triangles are similar, so find the value of x and y. So in order to create that, find the value of x and y, so we want to set up the proportionality statement for x. So we do know that CA over RP. So this one has the exact same ratios as the base of the triangles, which is what? AB over PQ. So CA, which is x. And then RP, it's 6. So that equals AB, so 7 over PQ, 14. So this one just reduced, so we got 1/2 equals x over 6. And then cross multiply, so we got 2x equals 6. So x equals 3. To solve for y, so we want to find out the measure of the third angle here. So 180 minus 30 minus 70, so we got 100. So that means angle y, it's 100 degrees. Because triangles are similar, so that means all 3 angles got to be congruent. So angle R, which is y, so it's 100 degrees. Okay, so now let's see what else that we have. The ratios of 2 sides of the similar triangle is 1, 2, 3. And the perimeter of the smaller triangle is 22. So 1 over 3 equals 22 over, find the perimeter of the larger triangle over x. Cross multiply, so 3 times 22, 66. 1 times x, which is 1x. So the measure of the perimeter of the larger triangle, then that would be 66 centimeters. With the unit, don't forget about the unit as well. Okay, so centimeters. Okay, so now let's see what else. So now let's talk about the first proportionality theorem. So this one is called the side splitter theorem. If a line is parallel to one side of a triangle and intersect the other 2 sides, parallel to one side of the triangles and then intersect the other 2 sides, it divide those 2 sides proportionally. So divide the sides proportionally. So you see that BD is parallel to CD. So the conclusion would be that AB over BC. So that has the same ratios as AD over ED. Okay, proportionality. Another way you can say that it's just like the shorter leg versus the longer leg of the left side of the triangle. So that has the exact same ratio as the shorter leg over the longer leg of the right sides of the triangle. Okay, so basically that's just like a general statement. Because those letters, sometimes we change that around, instead of using ABC, probably using XYZ, So here's one of the examples. So given that PQ is parallel to BC, so PQ is parallel to BC, and find a measure of CQ. So using that proportionality theorem, the shorter leg over the shorter leg of the triangle on the left-hand side over the longer leg of the triangle on the left-hand side. So this one has the same ratio as the shorter leg of the triangle on the right-hand side over the longer leg of the triangle on the right-hand side. So this one, let's say x. So cross multiply, so 6x equals 12 times 9. And before you do that, again, I always recommend students to simplify the equation first. Okay, so 6 over 12, it's 1/2 to make the number smaller. So 9 over x. So cross multiply, we got 1x equals 18. So x CQ, so it's what? 18. So solve for x, similar situation. So 3 over x minus 2. So that equals x over x plus 8. Again, those 2 line segments are parallel. So that means using the Splitter Theorem, Proportionality Theorem. So we got 3 times the quantity of x plus 8, so that equals x squared minus 2x. So quadratic equation, that means we need to bring everything together to one side, distribute first. So we got 3x plus 24 equals x squared minus 2x. Combine everything together, bring everything all together to one side, so we got x squared minus 2x minus 3x minus 24. So x squared minus 5x minus 24, so that equals 0. And this one, it is factorable, so x minus 8 times the quantity of x plus 3. So that means x equals 8. And also x equals negative 3, but this one is the measure of the segment, so x cannot be negative 3. So x equals negative 3 would be the extraneous solution, or the invalid solution. Okay, so now let's see what else that we have for another one. So example 3, in the diagram below, so triangle ACD, E is the midpoint on AD, so if that's the midpoint, so that means those two line segments must be congruent. And then B is the it's just the point on AC. B is just the point, not the just the point, not the midpoint, excuse me. Okay, so this one just the point. So this one just saying that segment EB, such that EB is parallel to DC. If AD is 3, ED is 6, so DC is 15. So find the length of EB. So basically using that proportionality theorem, so 3 over 6, so that equals x over 15. Okay, so find out what that is. And one thing that just got to be a little bit careful, because this one seems like it's two similar triangle. Okay, so that share with angle A in common. So you might want to say that 3 over x. Okay, so this one got to be very careful. If you just split it, it's two similar triangle. So one is a small triangle, ABE, and the other one is the big triangle, which is ADC. Okay, so ABE, and the other one is triangle ACD. So this one is 3. That means the measure of AD, then that would be what? 9. And then the base here is x. So the base of this triangle here is 15. So the way to set up the ratio, proportionality statement, so 3 over 9. So then that equals x over 15. If you try to set that 3 over 6, so that equals x over 15, then that could be considered incorrect. Okay, so got to be very careful. So 3 times 15, so 45. So that equals 9x. So x equals 5. So the length of EB is 5. So parallels proportion theorem. So if 3 or more parallel lines are intersected by 2 transversal, the parallel line divide the transversal proportionally. So if AE is parallel to BF, okay, so AE is parallel to BF, it's parallel to CG with those two transversal, AC and EG. So therefore the conclusions, AB over BC is the same as the ratios of EF over FG. Again, it's just about the shorter leg over the longer leg of the left-hand sides of the similar quadrilateral. You guys see that? If you just split it, then that would be two similar quadrilateral. And then EF over FG, so the shorter leg of the right-hand side of the similar quadrilateral versus the longer leg of the other similar quadrilateral. So it's the same kind of ratio. So this one, 10 over x, so that equals 14 over 21. Again, the shorter leg over the longer leg. So this one, things that we can reduce by 7, so divided by 7 top and the bottom, so we do have 2 over 3, cross multiply, so we got 30 equals 2x, so that means x equals 15. And then the other proportionality theorem is called the angle bisector. angle bisector proportionality theorem. If a ray bisects an angles of a triangle, so the ray AC, it divides the opposite side into segment that are proportional to the adjacent side. So what this one is saying that angle 1 is congruent to angle 2 because that is the angle bisector. So if this one is the case, so that means BC over AB, it's the same as the ratios of CD over AD. So BC over AB, it's the same as the ratios of CD over AD. Okay, so here's the one. So angle bisector. So that means the segment here, x, over the leg of this triangle, x plus 5. So that equals 12. The other segments of the base of this triangle over 18. So 12 over 18 reduced by 6. So we got 2/3. And then x over the quantity of x plus 5 cross multiply. So we got 3x equals 2 times the quantity of x plus 5. Distribute, so we got 2x plus 10 equals 3x. So that means x equals 10. Okay, so now let's do the one with the proof. So segment, well, not segment, line XA, it's parallel to line YZ. It's supposed to be a segment, so, but just saying that it's a line segment, it's not a line. And then angle XAY, okay, angle XAY is congruent to angle XYA. Alright, so it looks like this triangle would be an isosceles triangle. So you want to show that WX over XA, it's equal to WA over AZ. Okay, so we're using proportionality statement. Okay, so that means we need to prove that the the triangle got to be similar. So start off with the given statement. So again, instead of using lines, so just say XA is parallel to YZ. So if those two line segments are parallel, so one thing that we can include here is saying that the angle WXA is congruent to XYZ. Okay, so this one will be corresponding angles. And then after that, okay, so this one corresponding angle. So it looks like we need to use that the proportionality statement. Okay, XAY is congruent to XYA. Okay, so that one is given as well. Okay, so since we do know that those two lines are parallel, we can use that the Splitter Theorem. So that means segment WX over XY, it's equal to WA over AZ, segment AZ. So this one is by using the proportionality theorem, one of the proportionality theorem, Splitter proportionality theorem. Alright, another thing that we can state here, if this segment over this segment, it's equal to WA over AZ. So the last thing that we can state, so WX over XA So that's going to be equal to WA over AZ. So it looks like we need to use the transitive property. Okay, one thing that we notice, the base angle, they're congruent. So that means we can say that the segments, so we can say that XA, segment XA, is congruent to segments XY. And the reason for that, it's a angle side theorem. So after using that, the angle side theorem, so this one, we can say that WX over XA is equal to WA over AZ. The last one would be the transitive property. Alright? Okay, so now let's see what else that we have. And here's another example, it's quite similar to what we're doing. So DH is parallel to BC. So DH, excuse me, not BH, DH. DH is parallel to BC, and then HF is parallel to BG, and you want to show that the proportionality CD over DE. So that is the same as the ratios of FG over FE. So again, this one, you just want to show that the corresponding angles and using that one of those proportionality theorem. Alright, so thank you for watching the video today. So again, the rest of this is just a summary of what we're doing. So using those Splitter Theorem, triangle, angle, bisector theorem, so you can see that the proportionality, and also the other one, it's not the parallel proportionality theorem. Okay, so I'll see you guys next time. Thank you for watching it. Bye.